Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our today's video, we are going to discuss about most frequently asked interview questions on quicksort. We have already seen how quicksort works, what are the applications, what are the advantages and disadvantages. And if you remember, we have also derived time complexity and space complexity for the same. Based on whatever we have studied, let's try to answer the questions which are frequently asked in the interviews. So let's get started. The first question is, what happens if all the items being sorted have the same value? For example, if someone asks me, can you apply quick sort on this? Yes, I can apply quick sorting. But what about performance? Because why we take quicksort? Because with that pivot element gets, if there is a pivot element, it gets to its right position and all the elements left to it and right to it are greater than and left to it are less than it. So this helps, right? So in case we have the same value elements, what will happen? The quicksort performance will degrade because if you remember if we do 1, 2, 3, 4 and 5, if we take 1 as a pivot element, in that case, if problem is of n size, next problem will be of this size, 2, 3, 4, 5, that is n minus 1. And then again, next element of n minus 2. So you get a unbalanced. What you get is the unbalanced recursion tree, that is skewed recursion tree, right? Therefore, it will have a worst case scenario, that is O of n square. Because here, whatever pivot you select, right, it won't make any difference to you. Correct? If you select the first element, if you select the second element, or if you select the middle element or a random element, it becomes inefficient. Therefore, so if you have same value, the performance of quicksort degrades and it takes the worst case scenario. Let's go to the next question. What are the some ways by which quicksort can be optimized? Now quicksort can be optimized by choosing the pivot. You remember? For example, if you already have some of them sorted, you take what you do. You can take a random number, you can take first element, or you can take last element. Are you getting it? So based on checking the complexity and the elements in an array, you should choose a good pivot element. So if you choose a good pivot element, your chances are good that it have a good you can optimize the this quick sort, right? So best case is you select random, okay? That way also you can optimize it. Now other thing, it is called as optimizing the base case. Optimizing the base case, what you do basically, you have a problem, you divide into two subparts, right? So if you apply some different algorithm on sorting these, that is implementing an alternative sorting algorithm for these subarrays, can also reduce the overhead of the recursion. Basically, you apply quicksort here, then here and there, right? So there is an overhead of recursion. Instead of that, if you apply some different, because now the let's say this is a large data set, because quicksort is good for large data set, right? So I'm applying quicksort on large data set. At the end, I got smaller data set, and there are a lot of algorithm available which can work very efficiently for these smaller data sets, right? So you use them. So this will help you to reduce the overhead. Are you getting it? So what are the ways to choose pivot carefully, right? In case you don't want to you see the array and want to choose pivot, the best way is you choose pivot randomly, right? So can we modify pivot element while performing the position partition step? Yes. If you remember, I have taken some of the example also where I have changed the pivot also. In some example, I have changed the initialization of ing also. In some example, I have taken infinity as boundary conditions. In some of them, I have not taken infinity as boundary condition. So yes, the question answer is yes. It is possible to modify the pivot element while performing the partitioning step in the quicksort. Yes, you can change while you are performing the partitioning step, right? For example, you have taken one partition, right? So here you get the pivot element, then you get a subarray. Now you can take the last element as a pivot in this case. You have taken first as pivot, but for this array, you can take this as pivot. What is that? Are you getting it? So quick sort is dash and not dash algo. So quick sort is stable algorithm? No. It's in place algorithm, yes. So quick sort is in place algorithm and not a stable algorithm. What do you mean by stable? Stability refers to the property that element with equal value retains their original order. Remember? And we have discussed already. There is first question like this is again this, and we have discussed that in advantages and disadvantage that quicksort is not a stable algorithm. Are you getting it? So if you can retain the original order, for example, 2, 3, 8, 16, 0, 2. Now this is first 2, this is second 2. So when we are sorting it, 0, 2, 2, first 2 should come. That is what we call it stable algorithms, right? So the order of equal element may change here because of partitioning. So we don't know. So that's what. Now there is some of the questions which compares different algorithm, quick sort with merge sort, okay, quick sort with heap sort, right? So you can write that quick sort is an in-place algorithm, merge sort is a stable algorithm, right? When you talk about heap sort uses what? Selection sort. That there, if you remember right, its average time complexity is n log n. Merge sort, we need extra space also, right? So in case you know these algorithm, you will be able to find so those differences. So here you need extra auxiliary space, right? Because you need to merge it back. Are you getting it? But here what we do, instead of merging, we basically sort these subarrays. That is the big difference. And then heap sort it, we have already known that, right? Merge sort is a stable, where quick sort is not stable, right? So if you have not seen what is merge sort and heap sort, I will recommend you to watch our videos on merge sort and heap sort. Now, when should we use quicksort? A good example is when you have large data set. And if you remember in application, we have discussed that if you need to generate random this crypto keys, right? Encryption keys. There you can use it. If you have to reduce IO operations in distributed systems, you can use quicksort, right? These places, application of quicksort. Now then there is one application called as parallelized, if you remember, right? So how can quicksort be parallelized? Parallelized means you can, you know, for example, I'll just say, so this is divided here and this is divided this way. Parallelized means you quick you can work on these subarrays concurrently. This is what the parallelization, right? That's why we call it good. We can use parallelization. Parallelization is nothing but it's not like at one time you should do this, then you should do this. No. On parallel you sort this, this is done, this is done. Therefore, the problem is solved. Are you getting it? So that is why quick sort can be parallelized. So these were some of the most important and frequent questions. Otherwise, there are some of the questions which are very general, like what are the time complexities in best case, average case, what is tail recursion? This is, I remember I have discussed this in advantage. Tail recursion is nothing but when in an algorithm, last operation is a recursion operation and there is no operation left out of it. That is called as tail recursion, right? So those are the fundamental questions which are asked, which we have already covered. So if you like our videos, please do like, share, and subscribe. Thank you.